Let's go over the coronavirus cases in the USA. So from worldometers.info, let's do a refresh on that, make sure we got the latest and greatest. Supposedly we got 33,346 infections in the US and 414 deaths. I'm not going to go over the recovered. That doesn't make much sense to me. And there's a breakdown here by a state, with New York and Washington leading. So there you go. One thing about this where you can get individual stats per day is like daily new cases in the United States. So for example, March 21st, which was yesterday, we got 4824. March 20th, 5594. March 19th, 4530. March 18th, 2848. So I'm interested in new cases and daily new deaths. That's what I'm interested in mostly for the stats. 46 on March 21st on deaths, 49 on March 20th, 57 March 19th, March 18th, 41. So I basically went through all this stuff here and dropped it into this spreadsheet here. I put the 22nd in red because it appears there's a discrepancy in the statistics reporting from New York. So I'll put that in red and we'll talk about it. But anyway, so I basically started the spreadsheet making the stats from roughly February 29th through March 21st with a question about March 22nd. So in this column I have the deaths reported. In this column I have the added cases. And if you want the cumulative, the deaths on each day is this right here, and the cumulative added cases here. Alright, so what's more important for you mathematicians is the rate of change of deaths and the rate of change of added cases. So I just called it the first derivative of the deaths in this column here, which is basically this column minus that column. Alright, and on down. First derivative added cases is this column minus this cell minus this cell, and on down. However, what I did was a second derivative, so we'll know the rate of change of the rate of change, which is very important also. So the rate of change of the rate of change of deaths is basically this cell minus that cell, and for the added cases, this cell minus that cell, and so on. Essentially, these two are the first derivatives, these two are the second derivatives, and these are the integrals, more or less, if you want to do some data analysis here, which we'll do. So those of you who are not math guys, wait up for the charts, the graphs here I'll show you, so you can get a better intuitive sense of what's going on. So as you see in March, we start out with low numbers on added cases and deaths, and then we start ramping up a bit, a lot actually, as you would expect an epidemic to do, or something that follows the diffusion equation process of a target penetration population. All right, so let's take a look at the graphs of the deaths and deaths added. Now there we go. There's the graph of it right here. Let's zoom in here so we can see it good. And notice the last point looks like an outlier. I'm not sure if that's a real data point, just FYI. We'll have to check back probably tomorrow to see if this is real, but it doesn't look real to me. So anyway, we expect an exponential function and then an inflection point. It looks like the inflection point came around these two dots here in deaths. Added cases, let me get rid of the trend line so I don't confuse you non-mathematical people. So here's added cases. You expect an exponential up until the inflection point, which is either these two or these two starts inflecting. And remember, the final stat, I think, is an error from the New York cases. We'll figure that out tomorrow. First derivative. deaths. So remember, this is deaths right here, and this is first derivative deaths. So you know that the rate of change goes up here and it comes back down, up, you know, sharp rates of change, and then suddenly right here you see it going up, right? This is the quick rise in the rate of change, and then suddenly it rises pretty quick here. All right, so that's the top on the rate of change. Obviously, if you want to count this one out, because I think it might be an error reporting from New York. So as the rate of change goes up, you would expect the graph to be sharper right there, which it is. It's kind of sharpest right here, right? However, you see the rate of the first derivative, the rate of change starts going down here and very much down here, and then a slight blip right there. All right, and you see it obviously. So the rate of change does some changes right here, in roughly the inflection point, and then the drop off here. Okay. All right. So let's see. And the first derivative added cases, roughly the same. You get a big increase in the rate of change, and then the rate of change drops off here. That's your inflection points. First derivative added cases, same thing. Roughly your inflection point is either here or here, and then you get a slowdown of the rate of change here, and then a drop. Okay, like I said, with the exception of this final point here, which we'll probably talk about later. Or maybe tomorrow. Okay, second derivative, the rate of change of the rate of change. I guess the important point is that this trend line was going pretty steady. If you like draw an imaginary line through here, and we might be able to do that with a trend line just to give you an idea what it might look like. There you go. Linear trend line. There you go. So if you kind of get rid of some of the noise, you see like a trend line here. And it looks like we had a dip in the last 3 days here in the rate of change, and it looks like it should be going this way probably. Again, we have a spike here that we've got to figure out what's happening probably tomorrow to see if it's an error in data or if it's real. We'll find that out tomorrow. Second derivative deaths. So you kind of sort of see it coming this way, and then it looks like it wants to come down if you ignore this one right here. And then a second derivative added cases. Again, ignoring this line, let's put a trend line here so we can kind of sort of see where it wants to go. But you see it kind of curving down right here. And it might curve down here if this is an error. We'll find out, like I said a few times. Cumulative deaths. Okay, this is the integral, essentially, of the deaths. For those of you who want to... if you want to do calculus, discrete calculus, cumulative deaths and cumulative added cases. And you'll notice the inflection point here, where the rate of change kind of starts slowing down. All right. So here's all of them together. The added cases in blue, the first derivative added cases, and the second derivative added cases here. So you see, again, minus the final point, things are taking a dive bomb here. They're coming down. And that's a powerful signal whenever you graph the core. Again, you can eyeball it, but you want to see, hey, are these things right here really changing? So you do the calculus and do the derivatives to kind of see if we're reaching a real inflection point, looking further down the line, right? And so you can see that coming down on these two lines, definitely. And if you can eyeball it here, kind of this is slowing down, that's going down. So you can see the inflection point in the last, those data points would be the last 1, 2, 3, 4, 5, last 6 days. The inflection point's going down. Again, ignoring this outlier, which is the last point. And then the deaths. Now this, you see a little bit less of a phenomenon. This one right here is a clear phenomenon on the added cases, with all three graphs pretty much look like they're definitely inflecting down. This one right here, you see the first derivative definitely inflecting down. The second derivative inflecting down here, but there's one point on the second derivative that appears to be going up here, up this way, which if you can use your imagination, it's these 2 points here. You see it coming down, but then it's slowing down here. So that's that indicator from the second derivative, more or less, indicating that slowdown of the rate of change. All right. So that's one thing I wanted to make sure you guys saw, is that in the stats, there's definitely something changing when you look at the first derivative and the second derivative. Again, you math geeks, this is discrete mathematics, not continuous mathematics. So don't get out the equations on this, just do the straight up delta on the functions instead of the formulas you'd find in your calculus textbook. Added cases. Let me get rid of that trend line so I don't confuse you there either. There you go. All right, so those are the basic stats. So what we're seeing definitely in the last 6 days, 2, 3, 4, 5, 6, I miscount. There we go, 6 days right there. So this is the core data right here in the last 6 days that indicates, using the derivatives, that there's a definite change going on in the data for the last 6 days. And you can definitely see that in all the derivatives. You can kind of sort of see it on the core function, but it's very clear on the derivatives. And there's a change going on. And of course, like I said to you guys, it looks like that final point looks like noise to me. We'll find out in the next few days whether it's noise or a different way of counting out of New York. So if you look at these graphs here, New York, let's see, now has 15,790 infecting cases, an addition of 5,400 today. But look at yesterday, roughly 2,000 new cases yesterday, and at 10,000, and today they jumped up to 15,005. So this looks like noise to me, probably based on the way they, maybe a new testing technique, or they're just faking the numbers. It's a very good possibility that, being that the news media has their cameras pointed on all these phenomenons, people could start fudging the numbers maybe. So look out for New York, that might be fudging the numbers. Let's check some of the other states and see if we see any weird changes. You see all the other states look about normal changes, nothing weird. Like say Washington, 1793 today, I'm sorry, 1793 yesterday, and then 1996 today. That doesn't sound too much out of the ordinary. So California, today is 1555, yesterday it was 1327, okay. For a big state, that's not bad. Let's just look at Texas, 598. Let's see, 598 today versus 473 yesterday. That sounds about right. So the stats are not overblown there, but this big change in New York looks a bit weird to my eyeballs. So it's roughly 2,000 all the way up to 5,400. That's a big jump. There's something going on in New York. I guess that remains to be seen. Every other state looks about right. I don't see any serious data errors that pop out of my eyeballs just looking at that. Again, going to this graph, this big spike that came out today apparently might account for that New York thing. We're going to figure out what that is. Just so you're on the lookout for possible different data collection techniques or data fraud. That is New York, and I mean, seriously, who trusts New York, right? Right. All kind of weird stuff happens in New York and California, so you don't want to trust those two states with their data if something weird starts happening. Okay, so let's go back to the data here. Let's look at a different country. Let's try, let's go to China. So corona cases in China, 81,054, and then the deaths is 3,261. Those of you who I was, putting jokes up on the screen or whatever the last few days 3,621 in the biggest nation in the world, population-wise, is nothing. That's barely an epidemic. So this is nothing, you know, in the grand scheme of things. You get more deaths from centenarians, people over 100 in the U.S. per year, roughly 20,000 centenarian deaths per year. So if you look at the spreadsheet of the countries, the total cases, it looks like it's organized into total cases, which, yeah, roughly parallels new cases, but the deaths is a bit different. So it looks like there's something goofy going on in Italy, because it's a much smaller nation than USA or China. Spain, because see, the deaths are pretty high in Spain, deaths are pretty high in Italy, and the total cases are high. However, Germany has a lot of cases but very low death rates. So there's something going on in the difference between, say, Germany versus Spain and Italy. These are relatively small countries compared to the USA and China. Yeah, Germany's pretty big, but I mean, really, in the grand scheme of things, it ain't close to China or the USA. And Iran has a lot of deaths. So it looks like Iran, Spain, Italy, China has a problem with deaths. So, and that discrepancy needs to be pointed out, okay, when you're looking at data analysis. So it's like your questioning is like, what the hell is going on with Italy? First, with the total cases being so high, with it being a small nation in comparison to China and the USA. Spain also. All right. Very high death rate given its comparison in size to China and USA. Now here's what's weird. China's the biggest country on earth, and Italy is quite small, and Italy has more deaths than China. That is weird. Did it really start in Italy and then spread to China, or vice versa? Or are these numbers all fake? Or is their way of counting deaths different than the Chinese count deaths? Right? That's another question you got to ask yourself when you're doing data analysis, for those of you data geeks. Okay, so Italy and China is, I did similar analysis for those so we can dig into the stats. There's Italy, 59K dead and 5.4K, I'm sorry, 5.4K dead and 59K infections. So you already saw China. So I put all these in a spreadsheet. So here are the Italy numbers here. So essentially I did the same kind of graph. Here's your core data, first derivative, second derivative, here's your integrals. So let's take a look at the graphs for those of you non-mathematical guys. Let me get rid of the trend line so I don't confuse too many people. What you're going to notice here is it's a purely exponential at this point, and we don't have any, well, we have a little bit of a slowdown of the rate of change here. But we all know that these graphs have a top-off point and they're going to come back down, right? So you know this is not the end of the story. And then once you see the sharpest rise in rate of change, and you know the top-off is coming pretty quick. This is deaths. Let me get rid of the trend line so I don't confuse you guys here. Here's added cases. What you're going to notice is a good bit of noise here. So if you draw that exponential I just took away, what did I put up there? Polynomial. You'll see a lot of noise, right? Looks like it's hugging around this line here, but you'll see a good bit of deviation noise. So there's something going on in Italy with a little bit of noise in their cases reported in. It's not a flat line. You would expect it to be relatively flat given if the reporting was fundamental homogeneous and they had a set standard by which to report cases and deaths. There's something going on there where it's not smooth according to a real epidemic curve, and which suggests it's either data collection methods are different from this day to this day, from this day, from these 3 days here, or these three segments here, and this segment, same here. This segment, this segment, this segment. So there's something going on in this segment versus, and there's something in between there. So this suggests there's something going on with the data collection in Italy. Now here's the interesting graphs when you do the first derivatives of the deaths and elsewhere. Watch. There's a lot of noise here. A lot of noise in Italy. So right here you don't see much noise. Of course that's the the bottom of the graph. There's a little bit of noise here. But once you start getting to February, what, 6th, there's a hell of a lot of noise here. If you put a linear graph through it, you can see it pretty well. So look all this noise. It's a lot of noise. Compare it to, let's say, the USA graph. First derivative. Let's find the first derivative USA graph. Here you go. First derivative added cases. There's not as much noise, right? There's a clear rise in the derivative and then suddenly a dive bomb. Now this would be noise, but we're going to find out in the next few days what the hell this means. So maybe they're putting noise in the USA numbers also that we're starting to see here. But anyway, this noise suggests either fraud or different collection techniques. But in Italy, it's very clear that the noise is probably either different collection techniques from segment to segment or just flat out estimations or fraud. No judgment yet. We'll have to figure it out later on. And because the first derivative added cases, same amount of noise. I actually see more noise back this way also. Around March the 1st, into February, beginning of March, see a lot of noise there. But a hell of a lot of noise here. The second derivative, same thing. Obviously, if the first derivative has a lot of noise, the second you would expect it to have some noise also. So in the Italian reporting, there's a hell of a lot of noise in there. Let me put a trend line here. Just so you can see what the noise is. Cumulative deaths, that looks like a pretty legitimate curve. I mean, you can notice a little bit of noise here, but not much. Now right here you're starting to see a little bit of noise with your eyeball. But if you wouldn't have done the first and second derivatives, you wouldn't have noticed that noise. Right? And here's all together. So you see the exponential rising, but you could tell by the first and second derivatives there's a lot of noise in there. Right? And the second derivative here gives you, this is deaths. A lot of noise in both the deaths and the added cases. Now the China numbers, they really start on January 23rd, and then the epidemic is over with middle to the end of February, more or less. See, we're in the hundreds here. See, their max is like about 5,000-ish or whatever, 2 to 5,000. And then it starts dive bombing, and once this gets below 100, you can call that noise, right? So the epidemic was over roughly at the beginning of March, middle of March, which is not long ago, when ours just got started, right? So China was end of February, beginning of March, roughly is when it stopped. Now you can clearly see that with the derivatives here. And obviously you can tell I was playing with the trend lines, but let's get rid of the trend line so we can kind of look at it naked. So you see it rising, and then it reaches the top off, and then it dive bombs, and you get a long tail here, right? Now the China data has a lot of noise right here, right? And then obviously this looks like a little bit of noise here. Probably they adjusted their data collection techniques right here. You can kind of tell because the line's not that straight. However, you look at the added cases, you see a good bit of more noises, and this is not even looking at the derivatives. So the China case, it does have kind of, you can see the exponential rising and then coming down, but there's a good bit of noise in the China. In fact, I got rid of the top thing here because the noise was so great that I just chopped it off. I think it went up to like, what, 8,000 or something at this peak here, which might be similar to what's going on in New York for the USA maybe. If you look at the first derivative, my God, it's just noisy right in the middle. You see that? Let me get rid of the logarithm, and let's just put a linear trend line here. So you can, yeah, there you go. So now you can see where the noise, so if you zoom in a bit there, there's a lot of noise in the China data, okay? So let's just keep that as an open question, like, okay, the China data seems to have gotten us started on, recognizing what's going on in the world, but there's a lot of noise in there. The first derivative added cases, there's a lot of noise there again in the China case. All right, so you see the first derivative just all over the damn place until it gets to here where it stabilizes toward the end of the epidemic. Like I said, beginning of March, end of February is when it pretty much stopped in China, if we want to call it an epidemic, right? Second derivative deaths, a lot of noise, still a good bit of noise, and you see a little bit of noise even in when it starts ending, but we know it's ending here, but just by looking at the first derivative. All right, I don't think I put them all together in this one, but here's the cumulative, which is strangely enough looks good when you eyeball it, but then again, if you look closer, you see some weird little disjoints there. Cumulative added cases, again, you see little disjoints here. And if you eyeball it close enough, you can kind of sort of see the noise, but it's not clear until you just do the derivatives, right? So the derivatives, first and second derivative, tells you where all the noise is. Okay, in comparison, let's look at the influenza numbers in the USA for the past few years. Okay, so for the influenza, we get tens of thousands of deaths every year from the influenza. So look at 2011 to 2019. So we got like, what, 61,000 dead in the 2018 ending, right? And then the minimum was like 12,000 or approximately, you know, in the 2012. The total cases infected was in the order of 35 million, 30 million, 29, 23 million, and a low of 9 million in the 2012 year. So, and then here's again the first derivatives, the second derivatives, and the cumulative here. So you see it kind of jumping around from year to year. So compare the deaths and total cases in the USA from year to year of influenza in general to what we're seeing cumulative deaths for corona, right? So we're in the hundreds here, but for influenza it's in the tens of thousands, right? So make sure you watch those numbers very closely whenever you see the media reports comparing this to a so-called epidemic or whatever. No, this is not quite a flu epidemic. It's not even as bad. You look at the deaths per all these years, 11 to 19. It kind of goes from here to here, min and max. Total cases, first derivatives probably don't mean as much on the yearly basis. The first derivative is probably first and second derivatives are most useful for when we're in the game and we're trying to estimate how bad it's going to get. That's where the first derivatives are really, really helpful as to where we are, where inflection points are, where the noise is, and stuff like that. So your first derivative and second derivative helps out when you're in the game, but when you're looking at the yearly numbers, it's probably not going to tell you much. So keep that in mind as you look at these numbers here. Okay, guys, I hope you like this. Go out to this website if you want to see what the live cases are. Apparently, a worldometer, a worldometer, where you can get total cases for each country or total cases in the world. So this is the world view here, and you can view by country, and essentially you see the most cases, I guess, or deaths. Yeah, total cases mostly in this order, and you can either drill down the USA or any other country for what they're doing. And like I said, there's a bit of a weirdness going on in New York for the USA data that's causing a lot of noise in this final point reported in today. So be careful of that, but otherwise the USA data doesn't look like it's too crazy before we saw this point here. So look out for New York. If I see any other weirdness of data, I might report it in if I do some more videos here. So there you go. We're trending down with the exception of the data reported in today, which is good news. Again, unless this might mean something, but I doubt it does. So if we take away these 3 points, we're trending very well to stop at the top of the curve of the epidemic. So it looks like the added cases should be topping out right here. Probably you'll see the line topping out like that. Okay. So let's now look at the China report. This is the core report from the China Center of Disease Control, I think, China CDC Weekly. So this is the abstract that basically informed the world about the coronavirus out of China. Let's see, volume number 8. Good. So they analyzed data of the coronavirus in China, and they broke out the results, and then right here is the baseline characteristics broken out by age, 0 to 9, 10 to 19, blah, 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 everything like that, by sex, by occupation, all kinds of stuff they got here. So what we want to look at is deaths. for the China report. So you look at the time of the report, this is the confirmed cases and deaths, right? All right. So what's kind of interesting is that the biggest cohorts of those being affected is this cohort right here, from ages 60 to on up, gets the biggest. So that's 30, 60, 80, over 80% of the cases were above 60. A little bit for those in the 50s that have heart disease and hypertension, but for the most part, if you're below 50, you're in the weeds, right? On the sex ratio, the males get it more on the 63 versus 36% of deaths. Confirmed cases, then it's roughly 50-50. Occupations, let's just do a quick look at this. There's the other, which doesn't mean anything in stats. Farmer labor, maybe we can try to figure out what that means. Health workers, lowest percentage, right? You would think health workers get affected by the virus, but they don't. Why? Maybe there's something about this. Oh, retiree, there you go. If you're retired, damn, you get a really big probability that you'll get hit, 20%. Or if you're a farmer, 22%. So that must mean something there. Some of you scientists might dig into that. Broken out by province here. Let's see what's some good stuff we're going to go into. There you go. Here's the graphs of breaking down into the age sector on the Wuhan province, the Hubei, and China in general. This is the one we want to focus on. It's China overall. So it looks like in some of these provinces, certain age groups got hit pretty hard, like the 50 to 59 got 22.4%, and then the 40 to 49, 19.2. Makes you wonder what's going on there when the breakout happens in detail. All right. There might be some discrepancies there because I think they published this pretty fast. And here's kind of the graph of the curve. As you know, an epidemic gets started, it starts out really slow, then the rate of change sharply increases, and then it sharply tops off really quick. After the very sharp increases, you'll see the top off, then a gentle long tail coming down. And you'll see some extraneous data here, which is noise, right? Or like I said, change in data collection techniques or whatever that is. By date of onset, date of diagnosis, so there's a difference between the onset of they're assuming the onset of symptoms and the diagnosis of the symptoms. So there you go. You're going to see that that curve, kind of a diffusion curve. Subgroup findings, Wuhan. All cases among health workers. Interesting. Discussion. And there's some discussion, and then they acknowledgments, etc., and references. So this is a pretty good informative report to get started that the Chinese CDC published, assuming this is not information warfare. I mean, we can always suspect geopolitical rivals given information warfare, but this looks pretty good to me. From a scientist sort of point of view, it looks pretty good. I guess it remains to be seen if this is all good. Looks good to me. But there you go. Very good stuff from the Chinese Center for Disease Control, I'm assuming. And that's that. We'll end on here. I appreciate it. You guys take care. Have a good evening. Thank you.